Okay, so let's start with well, making a review of what we talked yesterday. You might remember that in the PowerPoint presentation, actually, we had a note. Okay, the note said talking about tight tolerance. You might remember that we noticed that a tight tolerance can also be referred to as close tolerance. That means that you have almost no tolerance acceptable or admissible in your project or system.
In
And
this case, in this, well, sorry,
mhm,
in this case, we don't have variation, no?
mhm.
This
Okay,
is,
yes, we can
yes,
say that well, in this case, we accept no variation or
uh-huh,
almost no variation.
okay,
We have some really close limits to the
okay,
ideal measures.
tight tolerance, okay.
Mhm. And in this case, the opposite of the tight tolerance was known as loose tolerance, loose with double O.
Tolerance.
In this case, that refers to that we have a big tolerance or a big different range between the measurements.
Mm,
And as I told yesterday, tight and loose tolerances are relative. Why relative? Because of course they depend in the area, in the work area or the working area that you are applying it. As an
mhm,
example, the book told us that a plus minus 1 millimeter was the example.
mhm,
If we talk of concreting, like in civil engineering, the 1 millimeter tolerance would be known as a tight tolerance because it's extremely accurate, at least when we build skyscrapers, houses, buildings, and stuff like that. In concreting, the 1 millimeter is a tight tolerance. But when we
tolerance.
talk about metalworking and stuff like that, well, the 1 millimeter is considered a loose tolerance because as a metal can be machined to within a few hundreds of millimeter. That means it's a little
Uh,
bit easier to manipulate the metal than the concreting. That's
mhm,
why it's the same measure, 1 millimeter plus or minus, but it's relative. I mean, concreting that's a lot, and in metal that's not a lot.
so it depends of material. Uh,
Hmm.
mhm, okay.
Yes, and the exercise F4 book. Let me just change the slide to that one. Um, give us an activity, a quiet and quick fast activity. It says that in some situations, the engineers describe tolerances using the plus or minus. For example,
Yes.
plus minus 1 millimeter.
Yep.
And that in other situations, they use within. That will be within 1 millimeter. So the activity that the book suggests us to do was to discuss the difference, and that was the homework that I told you to do, to discuss the difference in the meaning between the concepts or descriptions of plus, minus, and within. You were able to mention some examples if it was necessary. So I don't know what it's your conclusion. What do you got as an idea in the difference between plus minus and within? What does it depends, or what does it depends in?
Well, I think it depends on variation. The
Mm-hmm.
variation in one specification or reading
Mm-hmm.
um, uh, related with the accurate uh, when I use plus and minus,
Uh-huh.
the, I consider the maximum and minimum of range of the specification within tolerance or um, within or without tolerance, no. But describe when I describe with another difference
Mhm.
using minimum or maximum. I have one idea about the critical specification.
Okay.
Is not similar to the plus or minus. I think this is the point, ideal point of the dimension can increase or decrease. And I have so much. I have so much um, tolerance, no.
Mhm.
Um, but if I looking for one specification talking about I don't know long, uh, I have to consider the highest or lowest point, um, or consider the variation specifically with readings or measurement
Mhm.
about one area. No, it's a little a little difficult because the consideration is similar, but I think when I talk about differences, talking about accurate specification or specification
Mhm.
uh, ideal with ideal readings, but I think it's the better. No, it's better when I
Uh-huh.
talk with minus and plus. You know, it's
Yes.
it seems like that. No, it seems like be that.
Mhm. Okay. So in this case, we refer to plus and minus and versus within with some different concepts. They're similar, yes, but sometimes they differ a little bit. So uh, the book gives us a conclusion that in this case, and you might be looking right now on the PowerPoint presentation, it's that a plus minus, as an example, 1 millimeter means the size may vary by a maximum of 1 millimeter either side of the ideal dimension. However, no point must be further than 1 millimeter either side of this ideal size. Okay, so if we have, as an example, if we have a steel bar, okay, imagine the diameter
Okay.
of the steel bar is 100 millimeters. That means 10
Mm-hmm.
centimeters. And we have a
Mm-hmm.
plus minus variation of 1 millimeter. Okay,
Mm-hmm.
so in this case, the
Okay.
maximum is 101 millimeters and the widest point, and the minimum it's 99 millimeters. Okay, so
Mm-hmm.
that's
Okay.
the maximum total variation between the widest and the narrowed is 2 millimeters because the maximum is
Millimeters.
101 and the minimum 99 millimeters.
Yes.
So the variation there it's 2
Mm-hmm.
millimeters. Okay,
Mm-hmm.
and in
Okay.
within, when we said within 1 millimeter, that means that we describe only the total variation in size. This means they may vary by a maximum of 1 millimeter above the ideal dimension or a maximum of 1 millimeter below the ideal dimension. Okay, so within help us to describe the total variation. Meanwhile, the plus minus give us the exact not variation, but the size. Okay, it focuses more on the distance that it can grow up or grow down. Meanwhile, within, in this case, it talks about all the variation between the maximum and the minimum. Okay, as an example
Okay.
for the within, we might have, for example, the same steel bar. the minimum diameter is 100, we said, and the maximum would
Mhm.
be 101. So it will
Uh-huh.
be within 1 millimeter. And the same
Uh-huh.
as would a minimum of 99 and a maximum of 100, the minimum is 99.5 and the maximum 100.5. That's 1 millimeter in variation. Okay, so in within we almost find like a range. Like
Okay.
like a range between the widest and the narrow size. And in plus minus, we pay attention more in the
Mhm.
difference between the ideal point and the minimum
Uh-huh.
plus
Mhm.
the ideal point and the maximum. Okay,
Okay.
so that's like
Okay.
the example that it give us in here. Another
Yes.
difference that we can mention,
Mhm.
it's actually that, for example, what could it be? The
But
concrete
I have one.
surfaces. Uh-huh.
Okay, I have one example
Mm-hmm.
for that plus and or minus.
Mm-hmm.
It, I write down about the Y. If the Y for one fork in a lift truck is 340 millimeters standard, when I have plus plus or minus 2 millimeters. So I have a fork. You know what is the fork? The fork is
Uh-huh.
is a
The
what-
forklift.
yes, the fork. Well, in this
Mm-hmm.
case, just the fork. The fork is the teeth of
Mm-hmm.
the lift truck
Okay.
in the front of the truck. No,
Mm-hmm.
so this fork the wide is 340 millimeters.
Mm-hmm.
This is the standard or the ideal dimension. But this fork has can be or it can be 2 plus or minus 2 millimeters. In this case, the ideal dimension is 340, but I
Mm-hmm.
have one range about plus or minus 2 millimeters, right?
Uh-huh. That means that in this case, it can be 342
Yes,
millimeters
yes, yes.
as maximum
The
and
maximum.
338 millimeters as minimum.
Exactly,
Mm-hmm.
exactly.
And then the total variation between the
Mhm.
maximum and the minimum is 4
Yes,
millimeters.
exactly.
Mm-hmm.
Okay, okay.
And that
Good.
variation, it's the within 4 millimeters.
Okay, but that variation is 4
That's
millimeters.
the
Oh,
difference between
okay.
the plus and minus.
Yes, okay, okay.
The
Good.
plus minus refers to the ideal point, to the minimum or the maximum, and the within talks about the total variation.
Good, good.
That means the
I
difference
understand.
between the maximum and the minimum.
I understand better that
Mhm.
difference. Okay.
Perfect. So, uh, before we continue, actually, the book gives us an extension activity. It's actually a short activity about vocabulary.
Yep.
Some words that you might read and remember from the exercise 6B, where we talk about the super flat floors.
Okay.
In this part, we've got these 5 words: slab,
Uh-huh.
warehouse, automated guided vehicles known as AGV, and the high
High
bay
bay
warehouse,
warehouse.
and amplified. So, as an extension activity, we have to look for the meaning of this vocabulary. So I don't know if you wanna if you want me to give you like time for you to look out the meaning, or you know the meanings right now.
Well, maybe some words.
Mm-hmm.
I have a idea. Uh, I have idea related to the meaning, but I understand. I mean, slab um, could be a roof or flat or flat floor, or I imagine I imagine the flat floor or one roof or one specification about the concrete, the thickness of the concrete. I don't know.
Uh-huh.
I think is that the warehouse. Well, the warehouse is a big room, or a big room where keep I can keep the parts or products, essential products, where
Mhm.
I
We,
can uh, mhm,
we
yep,
have a word for
warehouse.
those products. Instead of saying like products and stuff like that, you can say goods.
Yes,
Hmm.
I can say goods.
So,
Goods.
well, I don't know if you are gonna write it down in the notebook or something like that. So a slab, we can refer it as the
Mhm.
block of concrete that makes up the floor. It can be laid on the ground, or if it talks
Support.
about
Mm.
higher stories, then it will be supported by beams and
Uh,
columns. That's the slab, like the block of concrete that makes the floor.
okay. Block of concrete. Okay.
It's as if you were playing with Lego. Those
Yep.
small squares that you just put it to make something, that's the slab.
Okay. Okay.
All the floor fragmented in different pieces.
Okay. I
Then
can. So
we got the warehouse.
I can call one block as like a slab. I mean, I can mention a slab to the
Mhm.
that
Yes,
it
I don't know.
items.
Sometimes in some warehouse, in this case, in some floors, you might see some lines
Mm-hmm.
like it's where it ended, and then it start another part. So
Okay.
those are known as slabs,
Okay.
like
Okay.
all the pieces of concrete
Yep.
put it together to make the floor.
Uh-huh. Uh-huh. Good.
Then the warehouse that you mentioned, it's a place where you store the
Mm-hmm.
goods, the products.
Mm-hmm.
So
Okay.
it's a building used for storing large quantities of goods.
Okay. So
The, uh-huh.
for the automated guided vehicles, I think it's like a remote control of the
Mm-hmm.
vehicles, remote control of the vehicles or system
Mm-hmm.
device, one device of the equipment of the
Mm-hmm.
equipment. I think is that I think no,
In other
I
words,
don't know.
automated guided vehicles, well,
Mm-hmm.
as a quick grammar tip, we
Mm-hmm.
use the word less,
Okay.
like less,
Uh-huh.
when you want to say that there's no of something. For example,
No. Uh-huh.
no hay cuidado o
Mm-hmm.
está descuidado sería care, que es cuidado, y less, careless.
Careless.
Sería
Careless.
no hay cuidado o sin cuidado.
No. Okay.
In this case, a synonym for automated will be driver. A driver, the person who controls it,
Yeah.
less. Driverless, that means no driver.
Mm-hmm.
That's like something that you might know. You can add the word less so
Uh-huh.
that the people understand that means know that. In this case, the
Yes.
meaning for AGV, could you please read it?
In warehouse and factories. Okay.
Could you
Okay.
please read the definition for
The
AGV?
high bay warehouse. In this case, no. I don't have one meaning for this. For
Okay.
this.
Well, before we continue to the high-bay warehouse, the AGV, it's the driverless vehicles which operate in warehouses and factories, like
Mm-hmm.
Amazon.
Amazon.
They use a lot of robots. Now, we have the
Yes.
high-bay warehouse. It's the same. It's a warehouse,
Mm-hmm.
But the
Okay.
only difference is that a height bay, it's because it's a tall warehouse. It's approximately 30 meters
30
high
meters.
with a multiple
Yeah.
level of racks for storing pallets.
Ah. Yeah, okay, this is for the tall.
Mhm.
Tall warehouse. Oh, interesting. High by
Yes.
warehouse. Okay.
And finally, you got amplified.
Well, amplify it. I understand like I mean electrical signal with electrical signal when I need amplify the signal
Mhm.
the electrical signal of the in current
Okay.
or electronic in electronic devices. No, I think is that
Mhm.
amplify.
In this case, well, the book told us that amplify means to make greater.
Okay, is that general meaning there, right?
Yes.
Just make it greater. Okay.
Great. Perfect. So let's do continue. Well, before we go to extension activity, let's go back to our book.
Okay,
So let's
this is my
change the
sheet.
slide. And it's page 33 now. You've got it on screen right now. In the next exercise, we're gonna listen to May. May, she's an structural engineer. She is talking to Lewis, who is a project manager. So they're discussing about the floor specification for a manufacturing plant that is currently at a design stage.
Okay.
So you're going to listen to the conversation and answer the following questions.
Questions.
Could you just please read the 5 questions so that you understand them?
Yes. Okay. In this case, we are talking about two persons, right? May
Yes.
and Lewis. Lewis. Sorry.
Uh-huh.
Okay. Okay. Number one is what has the client request with regard to the floor slab? The number two, what are free movement floors and definite movement floors? Okay. Number three, what issue does the engineer discuss regarding quality? Okay. Number four, what option is discussed involving grading? Okay. And number five, what can be done to the reinforcement to permit grading?
So these 5 questions, we have to answer them by the conversation between May and Lewis. Remember, both of them are working in the same project. The
Okay.
difference is that Lewis is a project manager and May is a structural engineer. So they have to list, well, in this case, to follow the instructions that the client requests. That's why the first question asks you to know the specifications that the client requests for the floor. As it's a new company, a new factory, actually it's a manufacturing plant, they might need some specifications in the floor. So you have to got those points, okay?
Okay.
I'm gonna play the conversation. I'm gonna play it twice, actually. It's a 2-minute conversation, so listen carefully. Just tell me if you're able to listen.
4.3.
Did you listen that?
It's okay, yes.
Okay, perfect. So listen carefully.
Okay.
Basically, the client has said they want a super flat finish over the entire floor area. That makes it a free movement floor where vehicles can run anywhere on it. But on the manufacturing process drawings, it shows precisely specified routes for these automated vehicles. So, technically, it should be a defined movement floor where you can just have a few narrow lanes for the vehicles, which are super flat, and then the rest of the slab is just laid to normal tolerances.
Right, so you're questioning the extra cost of doing everything super flat.
That's the main thing, yeah. The other thing is quality. To get the best finish on these super flat floors, it's better to lay narrow widths of slab in fairly long lengths. So ideally, you want lanes rather than big, wide areas.
Okay, but maybe they want everywhere to be super flat so they can change the layout of the production line in the future.
Possibly, but even if they want to do that, the surface can always be modified at a later date. It's a thick slab, so there's nothing to stop them grinding a layer off the top. In fact, we could increase the depth of the steel reinforcement slightly when we pour the slab, so there's some extra thickness of concrete over it. So, if they did want to grind a thin layer off a section in future, they wouldn't have problems with shallow cover.
Right, well, let's look into an alternative design for a defined movement floor.
Okay.
Let's listen one more time.
Okay.
4.3.
Basically, the client has said they want a super flat finish over the entire floor area. That makes it a free movement floor where vehicles can run anywhere on it. But on the manufacturing process drawings, it shows precisely specified routes for these automated vehicles. So, technically, it should be a defined movement floor where you can just have a few narrow lanes for the vehicles, which are super flat, and then the rest of the slab is just laid to normal tolerances.
Right, so you're questioning the extra cost of doing everything super flat.
That's the main thing, yeah. The other thing is quality. To get the best finish on these super flat floors, it's better to lay narrow widths of slab in fairly long lengths. So ideally, you want lanes rather than big, wide areas.
Okay, but maybe they want everywhere to be super flat so they can change the layout of the production line in the future.
Possibly, but even if they want to do that, the surface can always be modified at a later date. It's a thick slab, so there's nothing to stop them grinding a layer off the top. In fact, we could increase the depth of the steel reinforcement slightly when we pour the slab, so there's some extra thickness of concrete over it. So, if they did want to grind a thin layer off a section in future, they wouldn't have problems with shallow cover.
Right, well, let's look into an alternative design for a defined movement floor.
Okay.
Okay.
So, until this part of the conversation, May and Lewis were discussing the specifications, the future plans of these super flat floors actually, talking about the manufacturing plan and the AGVs.
Yes.
So, in the first question, they were asking us, what has the client requested with regard to the floor slab?
Well, I think the area that she wants to work or the activity, the principal activity or the main activity is the entire floor area. No? Entire floor.
Exactly.
Yes.
So that means the client requests, in this case, a super flat surface, a super flat finish for the entire floor. Okay.
Jets.
The second question asks us, what are the free movements and what are known as defined movement floors? What's the difference?
Well, she wants the movement and the movement floor, but she talk about the specific lanes in the super flat, no? In the super flat. The objective of her is the free movement. No.
Yes. But what
Yes,
is
I
mean?
think.
What do they mean by free movement floor and defined movement floors? They
What is
mentioned
mean?
in this part, actually, let me just click it in here and you might listen here. There it is. Let's listen.
floor where you can just have a few narrow lanes for the vehicles,
Oh.
but on the manufacturing process drawings, it shows precisely specified routes for these automated vehicles. So technically, it should be a defined movement floor where you can just have a few narrow lanes for the vehicles, which are super flat.
So in this part, she mentioned about the free movement floor and defined
Yes.
movement floors.
Yes.
And she
But
defined
yes, where the vehicles can run anywhere, no, on it.
exactly that's the free movement. And the
Yes.
defined movement floor means that the vehicle is not able
Yes.
to move everywhere,
That's
just in a defined lane.
okay.
So that's the difference. We would mention the free movement. Let me write it.
Yeah.
The free movement are super flat
Mhm.
everywhere. That means that the AGVs can move everywhere around.
Yes. Yes.
And on the defined movements, they have only a specific lanes
Lanes. Okay.
are super flat. That means they
Okay.
can only move in those areas, not everywhere.
Okay.
Mhm.
Good.
Great. Now look at the third one.
The third one is what issue does the engineer discuss regarding quality? Okay. I think is the high quality, no? Yes, the high
Yes.
quality finish, the high quality finish, the super flat, no? Or
Yes. Yes. So the movement in here, let me write it. But actually the issue would be long. Okay, long and narrow lanes
okay,
to allow a higher quality.
okay, long and narrow lanes.
Finish.
Okay,
Okay.
okay. Number 4. What option is discussed involving reading? Okay. In this case, I think she talk about parts of the floor, no? Parts of the floor. Uh, mm, eh, parts of the floor.
When they talk
About
about changes in the future.
yes. Yes, but she mentioned about the stage.
If it's not now, it's later.
Okay.
That means that this can be
Okay.
done in a later stage.
Later
That
stage.
means later, not now.
Mm,
To make all the parts of the floor super flat. I mean, if they don't want to do all the floor super flat, they can done a part, and later, if they want to, they can make it super flat.
good. Okay, and number 5, what can be done to the reinforcement to permit grading? Grading, yes.
Grinding,
Okay. She mentioned about concrete for positioned deeper, no?
Deeper, exactly.
Yes.
So the answer would be that it can be positioned deeper. Oh, in deeper concrete.
Okay.
in the concrete.
Right.
Perfect. Great. Those are the answers. Now, in the same part of this, well, you might look at letter B. It says that we have to complete the table that we have just below. We have 3 different names. We have the name of the dimension, the large dimension, and the small dimension, like opposites and synonyms. Okay.
Okay.
So look at, well, there's not an example, but you might look at this one. It says, number 2, what's the width?
The width.
Then, what's the name of the large dimension? And the opposite, it's narrow. Okay, all these words are looked out in the exercise 6B and the listening. But I think it's not necessary, the listening actually. I mean, look at number 1. We don't have the name, we don't have the large dimension, but we have the small dimension.
Small, it is short.
The question is it short?
Long.
Exactly. So
Yes,
in this case, the name of the dimension
what's the long?
is long.
Okay.
What's the long?
Yes, long because it is short. Okay, no small dimension. Okay.
Exactly. And then the next one. Well, in this case, if it's long,
is it long?
Well, it would be the other side actually. Is it long?
Okay.
And the name of long, it's length.
All right.
Do you remember that? Like, what's the length? ¿Cuál es la distancia? ¿Cuál es lo largo? Y luego preguntas, ¿está largo?
Okay.
Now look at width.
Width. Okay. Width is okay. Oh, it is wide. It's
wide. Exactly.
Yes.
Is it wide?
Wide.
And the opposite, is it narrow?
Is it narrow? Yes. Okay.
That's when you're talking about the descriptions, when you are asking for the description of the piece, an object, or something. Then the third one, it's what's the, and you have the large dimension, it's height.
Is it height? Well, is it height?
The height.
What's the height? Height, sorry.
Height.
Yes, height. So
Exactly.
small dimension, is it low? Is it low? Okay. The number 4 is what's the thickness? What's the thickness? Is it thick? Thick.
Exactly.
And is it thin? Is it thin? The number 5 is what's the, is it deep? Depth or depth?
Depth.
Depth.
Depth. Oh, depth.
Mention like that. Okay, depth. And is it shallow?
Is it shallow? Exactly. Great. So all these words actually complete in this case. So they have the same meaning, and in the other, it's the opposite.
Okay. Is it long? Is it short? Okay, what's the length?
I mean, it's the same question. I don't know. Imagine you have a steel bar, and you want to know the distance of the steel bar, sorry. So you can ask, what's the length of the steel bar? Or you can say, is it long?
Exactly. Or is it short?
If we're talking about small dimensions or large dimensions.
Yeah. Okay.
Perfect.
Good.
Let me erase this.
Yes, no problem.
Perfect.
We have the video in YouTube, right?
Yes. Yesterday's video, it's in YouTube.
Okay.
And the same for this one. I'm recording right now.
All right.
Then look at letter C. Could you please read the instructions?
May has done a reviews drawing for the floor slab. Read the extract from her email about the new design and complete the message using the correct form of the words in exercise 7B. All right.
Mhm.
This is the
So,
email.
you might remember that at the end of the conversation, Lewis said that they will find, they will look for another design for the super flat floor of the manufacturing plant. And in this case, May got an idea and she sent an email to Lewis. And the subject is revised floor slab drawing. So we're
Okay.
gonna complete this email by using the words that we just work here. The one of
Okay.
wide, width, height, height,
Length,
thick. We're gonna
length,
use those words, okay?
height. Okay.
So,
So I need to read this email. So please find attach a revisit drawing for the floor slab. Okay. Now reconfigure it for definite movement in order to accommodate guide vehicles.
1000.
1080 millimeters wide as specified by the client. Okay, we propose a standard of 1280 millimeters for each super flat lane. Okay, is length, right? And the
I
length.
propose a standard. In this
No,
case, as we're talking the
no,
same of the
is wide, right?
Width.
Wait, okay. Okay, of 1000 at in this case is at 14.5 meters. This is length of the longest lane on the network is within the maximum slab run that can be cast in a single concrete pour, thus avoiding construction joints and straight runs. On curved section, standard 8.5 meters turning radius is used as per the guide vehicle manufacturer's recommendation. In order to allow for the eventuality of future grinding, we have located to the top layer of reinforcement 10 millimeters deeper, okay, below the slab surface. This additional, if I was talking about deeper, is depth.
Depth, exactly.
Depth has not, however, been added to overall slab, which remains 275 millimeters. Overall slab. So we're talking about thick or no
Exactly.
thickness. Sorry.
Thickness.
Which remains 275 millimeters. Therefore, the reinforcing bars also remain in 12 millimeters diameter. As a result, the levels of wall-mounted process installation, many of which need to be fixed at a precise floor level. Okay, floor level is height, right?
Height.
Yes, because it's over floor level. It's the height are unaffected, no?
Unaffected. Exactly. Great, excellent.
I need understand that the reading because because when I try to understand each sentence, I need to back for read one more time.
Yes, you make a rewind of the reading.
Yes.
Okay, may I erase this one?
Yes, no problem.
Perfect. So we almost finished it. Actually, this is the last exercise because the next is the third part of Unit 4, you see?
Mm-hmm.
So
Okay.
let's see. Letter D, which two words in the email relate to circles? In this email, you read two words that talks about circle. Which ones are them?
Okay, okay. Which two words in the mail related to circles? Okay. What aspect of the circle do they describe?
The email. There are two
Email.
words that refers to a circle.
When I talk about the diameters or
Exactly. So there's one word, diameter.
uh,
And what's the other word?
I think is one circle or
Well,
not?
refer to that. Is this one?
Right. The radius.
Radius.
But circle
So
is
these two words are related to circles,
okay.
aren't they?
Okay.
You might remember the radius, it's the distance from the center to the circumference.
Okay.
And the diameter, it's the maximum width of a circle.
Yeah.
That means from one side of the circumference to another side of the circumference.
Okay.
Okay, and the radius, well, it's half the diameter.
Half of the diameter.
So talking about this one, let's make the extension activity. Just to understand a little bit more about the parts of the circle.
Exactly.
So you told me that you start actually doing the activity.
Number one is center.
Well, yes, it's the center. Yes, and the second one, number two, look at the point.
The second, I have segment.
Segment, exactly.
They are two segments.
Yes.
One per side. I mean,
segment, exactly. Segment 2 and segment. Which one? Well, later you got it. Look, go to number 3.
Okay, number 3 is chord.
The chord.
Chord.
Yes.
I read in one axis of the Google. They describe short, but I don't know if it's different. I don't know, short and chord, but I don't know.
You mean the one with CH?
Okay.
You mean that
number
one?
Number 4 is arc.
Number 4, it's arc, yes.
Number 5 is diameter.
The diameter, yes.
And number 7 is tangent. No, 6, right? No, 7, sorry. No, 6 is tangent.
6 is tangent.
Sorry, 6 is tangent.
Uh-huh.
And number 7, I think is circle. I don't know.
Well, it's segment. Also, remember you have segment times 2.
Okay, yes. And number 8 is radius.
Right? The radius, okay. Uh-huh. Number 8, it's the radius, yes.
In this case, I need a ruler for the distance around perimeter of circle.
No, I mean, it's a definition. Number 9, total distance around the perimeter.
Okay.
What's that name of that?
Circumference or
circumference, what? Excellent.
Okay.
Great. It's for you just to know like the parts of the circle. Imagine that it's like one of the sides of the steel bar.
Yes.
So it's just for you to know like the parts of the
parts of the steel bar or parts of the circumference.
Yes. So let me erase this one. And let me see, I think, yes, that's the last part of this section. Let's just go back to the book. And let me change, here it is. Now in the last one, you have number 8, we have another picture. In this case, it says the manufacturing plant, the one that we heard in the listening, and the one of the email, do you remember?
Yep.
So this manufacturing plant will be built from a steel frame. Okay, so the vertical elements of the frame will be universal columns.
Columns,
Look at
yes.
this section of the UC, and I want you to describe the different dimensions. And actually, sometimes it will be defined, the profile, by explaining what the letters on the sections refer to.
Okay, well, I need investigate that because I don't remember that.
Yes, but you might
dimension.
see, you have like the W, like a capital W, and a W, like a normal small W. That in this case, sometimes you have like the point in the middle, it's the web, and you got like a capital D, and you got a small d. You see?
Okay.
And you have an R and the T and the flanges. But I think it's not, actually you're gonna use the same words. The ones that we use in this exercise, the one of wide, thick, thickness, it's the same.
It's the same. Oh, okay.
Yes.
Wide is W or wide
In
is
this,
W.
uh-huh.
Okay. Radius is the
I
R.
mean, they are like capital and small, but because of the distance they are talking about. For example, let me use my spotlight. Here it is.
Okay.
So in this part, you might see, oh, well, I think this is obvious. This letter T, the one that we have in here, refers, you see the arrows, one's up and one's down. This letter T refers to the thickness. Yes. I can write it just like here, thickness.
Okay.
Thickness, okay? So that you remember. Then we have the small t. You see this small t?
T, yes.
It's the same. It refers to the thickness.
Okay, to the thickness.
But the thickness, let me write it again, the thickness of the web. Okay, the thickness of the web. That's one of the points in here. Now you might be asking, what is a web? The web is all that structure. Okay.
Okay.
Then we have the capital W. Okay, the one that is upside here, and this capital W refers to the width. The width actually. The width, like the it's the opposite. Yes, it's CH. To the width of all the column. You see? Well, the width of the flanges.
Okay.
Remember, let me write in here. These flanges are these bars from the bottom and the top. Those are the flanges. So this W refers to the width of the flanges. And by the other side, the small W, that one that is below and next to the thickness, you see?
Yeah.
This W refers in this case to the width of the column from the center of the web to the edge.
Okay.
Okay, so it's a width from the center to the edge. And actually you might see that in here. Let me make a line in red. You see it's from the center to the edge. Okay?
Yes.
Perfect.
Yes, that's the reference.
Yes, and then we only miss the letter D.
You see, we have is deep or
exactly the depth.
The depth.
So in this case, the capital letter refers to the depth of
or depth.
To the depth of the column.
Of the column. Okay.
Of the column in here. Let me write it. And the small d refers also to the depth, but not of the column. Of what?
Of the
what's the name of this piece?
Column now is
the web.
Flange. The web. Okay.
The web, yes. It's like the outside web and the inner web.
Okay. Okay.
So let's like the part in here.
Good.
And you see, that's the meaning of those letters. That's all the meaning of those letters. Ready?
Okay. Ready?
May I erase it?
Yes. Please.
Okay. Perfect. So until this part, actually that's everything for today, because the next is the next part of the Unit 4, the third section. We're going to start the next week talking about how to describe the design phases and procedures.
Okay.
So we're going to talk a little bit about the design phase, the design process of engineering.
Yes. Yes. It's common in this case of vocabulary.
Exactly.
Yes.
So let me just change that and stop.